Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you another code review. This is going to be on Kaggle's October 2022 Tabular competition. And basically, I had to look at some other code in order to complete the competition. So that's why I'm just doing the code review, and I'm not going to be making a blog post on it because I had to use other people's code just to finish it. And so what they do in Kaggle is whenever you go to a competition, they have a section called code, and some people make their code public, and when they make their code public, you can look at their code to see what they did to, get on the leaderboard basically. And so because I looked at other people's code, I was able to actually get on the leaderboard, which is what I wanted to do. So we're going to go ahead and do a review. So the first thing we're going to do is we're going to look at the notebook, and you can see that I had a public score of 0.2, and it took 197.3 seconds to run. And we will look at our problem statement. So this may be one of the most challenging tabular playground competitions to date. It just so happens that one of Kaggle's software engineers is an avid Rocket League player, and he's assembled a data set of Rocket League gameplay for this month's TPS. This month's challenge is to, given a snapshot from a Rocket League match, predict the probability of each team scoring within the next 10 seconds of the game. Sounds awesome, right? So I've never played Rocket League, so I don't know anything about the game, but I went ahead and decided to give it a go. And the reason why is because I want to do all of the 12 competition questions for 2022 so I can make a course on how to enter Kaggle's Tabular Competitions 2022. And so I have to do all 12 competition questions in order to make the course. So I created the program in Kaggle's Jupyter notebook. So what we're going to do is the first thing we're going to do is we're going to import the libraries. So I import pandas as PD. That does data processing, and it creates and manipulates data frames. I imported NumPy as NP, and what that does is that carries out numerical computations, and it also creates NumPy arrays. And I want to go back to pandas because in addition to pandas creating data frames, it also creates a series, and a series is just one column of data. And then after we've created NumPy, after we've imported NumPy, we're going to import OS, which goes into the operating system, and it retrieves the files that you need to execute the program. We import matplotlib.pyplot as PLT. That's a graphics library, and it plots the data points onto a graph so you can visualize your data. And we import Seaborn as SNS, which is a higher level graphics library, and it has statistics functions in it as well. So after we have imported our libraries, what we're going to do is we're going to load our files, and we're going to use OS to do that. And as you can see, we've got all these different files in here. So the ones that we're going to use for our submission is going to be the sample submission, and then you've got test, and then you've got I think you've got 10. I think it's 10. You've got 10 train files. So we're going to read all the files into the system. So the only one that we read in was train 0. The only one that we read in was train 0 at this point in time. just so you can see what train 0 looks like. It's 2,149,381 rows by 61 columns. So it's a very large data set. You can see the last two columns are Team A scoring within 10 seconds and Team B scoring within 10 seconds. So that's your target. So now what we're going to do is we're going to import TQDM, which TQDM is a library that allows you to create these little bars, because a lot of people like to look at bars. So input equals the input to the Kaggle CSV files. df train d types equals pd read CSV input plus train d types.csv. df test d types equals pd.read CSV brackets input plus test d types.csv. Train d types equals curly brackets k colon v for brackets kb brackets in zip df train d types.column df train d types.type. Test d types equals curly brackets k colon v for brackets k comma v brackets in zip brackets df test d types dot column comma df test d types dot d type brackets curly brackets. And then what we do is we create a blank array called train list. Now this is where we get our bar. For I in TQDM range 1, train list dot append pd dot read CSV input plus f train I CSV d type equals train d types, and then you print off train list. So it gives you the bar and then it prints off the train list, so you can see that this is the train list that it gives you. So now we're going to say test equals pd.read CSV input plus test CSV d type equals test d types test. So you can see the test file, and you can see the test file doesn't have the last two columns. It only has 55 columns, and you can see the train file. We can find the train file. Train file has 61 columns, so the train file has 6 more columns than the test file. Then we check the submission, and submission equals pd.read CSV input plus sample submission CSV, and then you can see submission. So this is what Kaggle wants to see. They want to see the ID, they want to see Team A scoring within 10 seconds and Team B scoring within 10 seconds. So then we're going to print train list 0 shape, test shape, and submission shape. So you can see train list 0 shape, test shape, and submission shape. Now what we're going to do is we're going to define our X and our Y values, and because we're using LightGBM, it doesn't have a multiple output function in it, and because it doesn't have a multiple output function in it, we have to define YA is train list 0, Team A scoring within 10 seconds, and YB is train list 0, Team B scoring within 10 seconds. And then we have to define our X is train list 0, and then you have to drop another number of columns. So you drop game num, event ID, event time, player scoring next, team scoring next, Team A scoring within 10 seconds, and Team B scoring within 10 seconds. And then axis equals 1, which means that it's the column that you are dropping. And X test equals test drop ID, axis equals 1, so the test is going to drop the ID. And axis equals 1 means it's a column. And then what we do now is we check our shape. So you've got X shape, YA shape, YB shape, test X test shape. So you've got the shapes of all of these variables. So X and X test have to have 54 columns, and YA and YB have only 1 column. So now what we do is we use sklearn's train test split to split the data into a training and a testing set. And so we have to do this twice because you've got a YA and a YB. So XA train, XA val, YA train, YA val equals train test split. X, comma, YA, test size equals 0.1, random state equals 42, shuffle equals true. And then we do exactly the same thing with YB. And then so we print these out. We print out the shape of these variables, and you can see that the training and the train and the val set has to have 54 columns on the XA, and the Y has only 1 column, and they have to have the same number of rows. So now what we're going to do is we're going to select our model, and in this instance what we're going to do is we're going to use LightGBM. So import LightGBM as LGB. So we have to have 2 models now, and the reason why is because LightGBM doesn't have a multi-output classifier, and because it doesn't have a multi-output classifier, you have to have 2 models. So model, let's just go back here. So model A equals LGB.LGB classifier brackets. Model B equals LGB.LGBM classifier brackets. And then you have to fit model A and model B. So model A dot fit XA train, comma, YA train, comma, eval set equals XA val, YA val, XA train, YA train. And then model B is exactly the same, except you're using B data in it. And then you're going to delete, when you fitted the data, you're going to delete XO, XA train, YA train, YB train, XB train, YB train, XA val, YA val, XB val, YB val. And I think that they did that because this takes a lot of memory, and it uses up a lot of space in memory, and I think that they decided to go ahead and delete these so they can free up the memory. That's why I think that they have done it, to free up memory. So now this LightGBM churns away and does its work. And then after it's trained and fitted the model, then, or the 2 models really, then we make predictions. So predict A equals model A dot predict propa X test, and you're going to use the first column, which in Python you've got a 0 and a 1, so in reality it's the second column. And then predict B equals model B dot predict propa X test equals brackets, colon, comma, 1. And again, that's the first column, but because in Python the number starts with 0, in reality it's the second column. And then so we print predict A and predict B. So you've got your predict proba for A and B. And then we prepare submission. So in the submission you have 2 columns. So submission brackets team A scoring within 10 seconds equals predict A. Submission team B scoring within 10 seconds equals predict B. And then we display submission, and that's another term that I don't normally use, because normally I would say print submission, but the person that did this said display print submission. So he uses terminology that I normally don't use. And then we take the submission and we convert it to a CSV file. And then when we have converted it to the CSV file, then we can submit it to Kaggle. And when I took this submission and I submitted it to Kaggle, I got a 0.2. But I had to have help to enter this competition. I had to look on someone else's Jupyter notebook to get the code together to enter the competition, because I don't know anything about Rocket League, and I have never worked on anything that's got like 10 data sets on it. But what I think from just looking at the code, the person that originally did this, that he only used the first data set, the train 0 data set. He didn't look at any of the other training data sets. But we got on the leaderboard, and that's what's important. It's getting on the leaderboard. And so I can say that I entered that competition and I got on the leaderboard. I even got a bronze medal for it, but I can't take the credit for that because I used somebody else's code. And so that way I can make my course at the end of the year, and how to enter Kaggle's 2022 Tabular competition. And I can say that I've entered all of the competitions, and this is the code for all of the competitions that I've entered. Okay, so I'm going to go ahead and conclude this presentation, because I've covered everything that I need to cover. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you very much for watching this video. I look forward to making more videos for you in the future.